Today we are going to do some math. Now don't hit next yet. This is pretty easy math, okay? So in the ITF plus, they really care that once we get to programming, but as far as like numbering and notational systems, you need to know base 10, which is what you've been counting probably your whole life, binary, which is a base 2 system, and then hexadecimal. Okay, so that's what we're going to talk about. We'll talk about those three things today. We're going to talk about throughput and how we like measure speed and stuff like that as far as like internet connection or traffic on the network. And then we're going to finish up. There really wasn't a great place to put this, but we're going to talk a little bit about intellectual property and copyright and things like that. So should be a short lesson talking about a little bit of math and some intellectual property. All right, let's go ahead and get started here. So again, we are in Module 2, Unit number 1, using data types and units. So what exactly are our goals for today? So first and foremost, we're going to recognize and use different notational systems, data types, and units of measure. Again, I talked about that a little bit in the intro. Notational systems, that's a big scary word that just means how we count things, okay? We can count things with base 10, which is like where we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we could also, but we take that same count, but we can represent that using binary, okay? And we'll break down like the charts and all that stuff, but that's all notational systems mean, okay? Is just how we represent what we're doing, because computers only know two things. They know on and they know off, okay? So if you break down everything that we do as it goes through the processor, all it can do is calculate zeros and ones, okay? Everything breaks down to binary. But with binary, I mean, if you look at some of those numbers, I mean, there's no way that you could quickly like glance at them and do math with them. It's just not what it's really good for. You know, the standard base 10 system that we use is really good for things like that. So each of these notational systems has a purpose, okay? One's not better than the other. You're not just going to start, it's not like metric and standard. It's not that. They're just used for different things. So for the ITF plus test, you just have to be able to recognize them and kind of what their purpose is, okay? We're also going to talk about different data types, and then we're going to finish up with kind of how data applies to business, but then we're also going to cover some things on intellectual property and copyright. So our base 10 system, or our decimal system that we're used to counting, has every single digit can be 0 to 9, okay? So I'll give you a second to kind of glance at this chart and for it to make sense for a minute, okay? So these are what are called our placeholders, okay? So the 1000th placeholder has a 0 on it. The 100th placeholder has a 0 on it. The 10 has a 1, and the 1 has a 2. Okay, so these are our different place values. So as we're going through here, there is no 1000s, there's no 100s, there's a 1, so we put a 10 here, and there are two 1s. So 1 times 2 is 2, so this is 12. Okay, so breaking it down, each column is worth 10 times the one before it. Now you might be thinking like, TJ, why are you overcomplicating this? I mean, we know how numbers work, right? We've gotten this far. Well, as we start looking at the next ones, keeping this kind of standard makes the most sense. Having this understanding of place value and having values in this section and how you do the math to get it. Okay, so again, the 1000 had 0, the 100 had 0, the 10 had 1, the 1 had 2, and that comes together to make 12. Okay, so now we go into binary. Binary is a base 2 place value numbering system. So you can see here, there's a lot more placeholders or place value things here, okay? And you notice There's no 2's here, there's no 3's, no 4's, because each column can only be a 0 or a 1. Okay, on the last one, we could go all the way up to 9. With binary, being that it's a base 2 system, it can only be a 1 or a 0. Okay, and instead of then each column being worth 10 times as much as the previous one, it is worth 2 times as much. Okay, so 1, 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128, and so on and so forth. Okay, but most of the time, when you are going to use this, there's one very specific time that you're going to use binary and you're going to write it out, and that is when you're doing subnetting. Okay, so memorize this chart right here, and by memorize I mean just memorize that you start with 1 and then double it. Okay, because when you take your certification exam, if you take it in person, you have a blank piece of paper. But then you also have, on the digital or the online version, they have scratch pads as well. So you can write this chart out on the actual chart or on the actual piece of paper right when your test starts, so you can always come back and reference it. So this is one of those things, maybe not for the ITF Plus, but again, it's good just to know it. Network Plus for sure, CCNA for sure. But just know that you start with 1, and then you times it by 2. Each column is 2 times more than the one before it. Okay, and what this boils down to is these are the on and off statuses for electronics. So as things like, especially with like networking, we send signals like this, whether that's on the wire, whether that's on fiber, however it is, we're saying off, off, on. And then at the other time, it's taking that information in and it's converting that back to data. Okay, it's a little bit beyond this section, but that's encapsulation and decapsulation, in that we have data, we break it all down to its most basic form, and then we send it across the wire, and then on the other side, we reassemble it. Okay, so again, for this level, for your ITF Plus studies, just know that base 10, each column is 10 times the one before it. Binary, each one is 2 times the one before it. Okay, so hopefully that all makes sense so far. We're gonna throw some letters at you. Okay, I swear this is like in high school or middle school. Whenever I started doing algebra, when they started adding letters, that's when I was just like why are we putting letters all up in our math? Well, we have to do it in IT as well. So hexadecimal notation. Okay, so hexadecimal is a base 16. Wait a second. Base 10 went 0 through 9. Okay, that made sense. Binary, just zeros and ones. Cool. But how do we go higher than 16? Our numbers only go to 9 and then they repeat, right? Because we go 8, 9, 1, 0. Well, now we have to add the letters. It's okay. Again, I'm not trying to lose you here. It all makes sense. It'll all make sense, okay? So each digit in hexadecimal can be 0 to 9, or A, B, C, D, E, and F. Okay, so, oh, hey, look, there's a typo on this because you can have D as well. So the way that I remember this is when we add letters to math, we go 0 to F in a hurry. Okay, 0 to fun. 0 to fun, right? That's what you were thinking. That's what I was. Yeah. Okay, so each column is worth 16 times the previous. Okay, so looking at this here, 1 times 16, 16. 16 times 16 is 256. 256 times 16 is 4,096. Okay, so if we have in our first column, we have 2. We put that right down there. In the 16 column, we have D, okay? So if we start at 9, 10 is A, 11 is B, 12 is C, 13 is D, okay? So we can take 16 times 13 and bring that down. So it's 208. And then 256 times 4, we have 1,024. So if we total this up, we get 1, 2, 3, 4. So if we have there's two ways that this is used. So if there's really big numbers and we need to put it in a small space, then we can use hexadecimal notation. But most of the time, where you're going to see this is when it comes to networking. Our MAC addresses are in hexadecimal, as is our IP version 6 addresses, okay? So again, with IPv6, we needed a way to not have the issue that we had with IPv4, which was losing or running out of addresses, okay? So we had to have a really big number. So that's why they decided to use hexadecimal, was because they could represent very large numbers with just a couple small place value numbers, okay? And when it comes to that, there's just some basic math that you'll have to do, but for me, in my 15-year IT career, I've never had to like add hexadecimal numbers necessarily together. But with IPv6, you might have to expand because it likes to shorten them. There's some rules when it comes to IPv6, so you might have to unshorten those by doing it's more logic than it is math. So don't get freaked out, okay? So let's talk about how we go from just that 0 and that 1 that we talked about when we did that whole encapsulation, decapsulation thing into larger like storage and things like that. So a bit is the very smallest piece, and that represents a 0 or a 1, okay? If we put 8 of those bits together, we have a byte, okay? And then from there, we just keep working our way up to large. You might have heard of megabyte or gigabyte or terabyte. That's just a larger amount of those bits that we started with, okay? So base 10 multiple of bytes are used to represent all storage sizes, okay? So we can see here we have a kilobyte or a kilobyte that is represented by KB. So to break that down, that is 1,000 bytes. So remember our place value chart that we had. So 10 times 10 times 10 equals 1,000, okay? Next we have a megabyte, which is 1,000 times 1,000 bytes. We have a gigabyte, a terabyte, a petabyte, okay? But notice I am saying bytes, okay? It is not bits, because this is the capital representation here, so it's a capital K, capital B. So that is a kilobyte, okay? And I wanted to take a minute to just talk a little bit about like hard drive storage. So let's say you buy a 1 terabyte hard drive. When you get it into the actual operating system, it might not be exactly, what did I say, a terabyte? So it might not be exactly 1,000 gigs, okay? It might be plus or minus a little bit, because again, when we're breaking this down to, it's really easy for marketing just to put 1 terabyte, when in reality it might be like 1,024, or you might see a different size in there, and don't freak out about that. That's just, again, it's easier to put terabyte, gigabyte, all that for marketing purposes. But it might be just a little bit, the operating system might represent it just a little bit different. Yeah, I've never heard of these kibibytes, mebibytes, or gibibytes. Those are new to me. Most of the time, I would say 99.9% of the time, you're going to use the base 10 versions, not the base 2 ones. There's probably very specific places in which you'll use those in, like more scientific research. But in our case, we use these base 10 versions. Okay, so now notice that our B's on this next slide went to lowercase. Okay, notice we are now no longer talking about storage, we are talking about transfer rates or speed. Okay, so this is represented in kilobits per second. Okay, megabits per second, gigabits per second, terabits per second. Okay, so these are always represented in our base 10. So the 1000, and then it just multiplies up. So 10,000, a million, and so on. But again, the biggest thing that you need to know is when it comes to speed. And when I say speed, I mean how much data is going through the wire, okay? Or how fast are we transferring our data to the hard drive? Whatever it is has this per second, that means we're watching it race by. How many times per second this data is going to go by? Whereas when it is the capital B, that represents bytes. So that is going to be the actual storage, how much data is actually being stored. Not necessarily at movement. This is at rest. When it's sitting there, how much can it hold? Okay. So the last one that we talk about is, when it comes to speed, is this idea of hertz. And what hertz stands for is 1 cycle per second. So when you're looking at processors and things like that, you'll see they have 36 gigahertz. Not really, but you'll see it represented in gigahertz, and that is telling you how many times or how many calculations that the processor can perform per second. Okay, so this is also referred to as our clock rate or our clock speed. Okay, so again, a hertz, an Hz, is representative of how fast our processor can process things, or any processor can process things. And it comes in megahertz, which is 1 million, or gigahertz, which is 1,000 million. So a lot of times you'll have, each core will have like 2.x gigahertz. Okay, so again, all the processor does is, basic math as it's coming through. It goes from the RAM onto that CPU. The CPU does some calculations and then spits it out. Okay, so when we're looking at hertz, we're looking at how fast it can perform those different calculations. Okay, so again, raw speed, the speed in which it can calculate, is going to be our processor. When it comes to our throughput, that's going to be our bits per second. When it comes to storage, that is going to be our megabyte, gigabyte, terabyte, things like that. Okay, so hopefully that makes sense. When it comes to, and we're going to talk a little bit more about this when we get really deep into the programming section, but there's different ways to, as we're building applications or other software, there's different ways that we can represent, whether that be a letter or a like a bucket to hold things, and these are our different data types. Okay, so what I mean by that is an integer is going to be a whole number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all going to be whole numbers. Okay, and then floating point numbers are going to be when we have that decimal in there. 1.2, 2.6, 3.2. Those are all going to be our floating point numbers, and those are going to be decimals or fractions. Okay, our Boolean values are going to be a true-false statement. Did you wake up today? True or false? Boolean, true. Are you awake? False, because I have not had my coffee yet. And then characters are going to be just a single letter or any symbol, maybe even an emoji. That's going to be a character. And then when you put a bunch of these characters together to make sentences or things with spaces in them, that is going to be a string. Okay, so in the basic understanding of coding, all I need you to know right now is binary is zeros and ones, and that's all a CPU can actually process. Okay, so what we do is we represent those values as we're building applications. We need to store these main data types. So we need to store an integer. We might need to store a decimal. Okay, and then that code, after we're done building it, we compile it. It gets converted into a language that the computer can understand, which is then broken down to just those zeros and ones. Okay, so just our building blocks. Okay, we have our zeros and ones, on top of that, after we're gets converted, it's going to be our integers and our booleans and these different tools. And then on top of that, we're going to see our user application. So they're not going to see all that code and stuff under the hood. Okay. So there's a couple of main, two main ones, especially when this is more important, I guess, for cybersecurity, that you'll have to sometimes break these different character sets down. But again, like I had said earlier, we had zeros and ones, and sometimes, we need letters and we need to represent things in different ways. So that's where these two main character sets come in. So we have ASCII, or ASCII, which is the American Standard Code for Information Exchange. It's kind of limited by the number of symbols it can have. So it has just your baseline, your space, your different math symbols, 0 through 9, colon, greater than, the ones that you see up here on the screen. And then it also has our characters or our different letters. So you can see each of these have a binary representation of what these characters actually are. So 010, 0101 is a percentage sign. Okay, so again, it didn't have a ton of characters and stuff like that. This was like the kind of the baseline of just the bare necessities, if you will, where Unicode has a whole lot more. So Unicode has international letters. It has a bunch of different symbols. You can see here, where it has up arrow, left arrow, and it goes on and on and on. So your homework for this video is to pause for a second and unpause until I tell you what to do, and then pause. So pause the video and go check out these different charts. So look up the ASCII chart as well as the Unicode chart just to get an idea for what they are. But at the end of the day, you just have to know that they are character sets, which is how we can represent different characters like the alphabet with binary, okay, which is zeros and ones. So it's really important, and as you study, it's funny, I was just doing some CISSP studying, and they were talking about this, and that is data is an asset. So when it comes to different companies, data is something just like the trucks that they own, or the cars that they own, the buildings that they own. Data is also an asset that they own, okay? So it's very important to invest into protecting that asset. Arguably, it's probably one of the most important assets that a lot of companies have. Okay, so there's a couple different ways that you can protect it, and those are called controls. Okay, so we can put technical controls in, we can put physical controls in, but we won't go deep into that rabbit hole. But just know that we need to protect this data. These zeros and ones at the end of the day are what we are protecting as a security force, as an IT force, as just a user at the company, and being aware of like phishing scams and stuff like that. It's our responsibility to protect that data. Okay, so another term that might pop up on the ITF Plus is our return on security investment, or our ROSI. You might have heard of ROI before, which is return on investment, but ROSI is return on our security investment, and that's how we can kind of justify, hey, we really need to spend money on this, because if we don't, and data gets out there, we could be sued, okay? And actually breaking down what that actually means. And it's very important to do risk assessment. If you've never heard that term, that is where you look at a situation. So for example, having data that is saved on our website, we're going to do a risk assessment on that. We're going to see who could potentially get access to it, what motives would they have, and then figure out, okay, what is our risk level? And then once we figure out that risk level, so what's the risk to the business, then we are going to figure out what to do with that risk. Are we going to put a control in place to mitigate that risk? Are we going to just accept that risk? Maybe it's low-level data, so it doesn't necessarily matter. So like news, for example, maybe it's a piece, like a blog post about a news release. So that's public information, so maybe the risk on that is rather low, so we're just going to accept the risk if that data gets out there, okay, because it's public knowledge. But maybe we're a company that works with social security numbers, that risk might be a little bit higher because that's going to put our users at risk. Okay. So when it comes to different security controls that are out there for that data, they come in a couple different classifications. So first and foremost, what can we do with the data? We can back up our data. So when it comes to you working on your personal computer, and even in an organization, ransomware is something that is really, really scary. And with ransomware, basically a infection gets on your computer, and then it locks up your data, and it holds the key hostage until you pay it in some type of currency, whether that is Bitcoin or whatever they ask for. Okay. So the best way to bounce back from a ransomware attack is to just wipe out the computer and pull from your backups. Okay. Hopefully your backups were not part of that encryption scheme, if you will. But it makes it so you can easily just back up all that data and get back online. Okay. But even before that, we can look at what's called access control. So when it comes to access control, we're making sure that only good people have access to the good data. Okay. So we do that by using permissions, by usage restrictions, which those two sound alike, but usage restrictions would be how could you actually use that data. Permissions is do you have access, to log in and see it. Data encryption, so making sure that when the data is on the disks or even in transit, we're making sure that we're like covering it in a cloud of confusion. So if people are on the outside kind of looking in, they don't understand what that data is. It just looks like a bunch of randomness as it's coming through because it's encrypted. And then finally, firewalls. Firewalls are, basically at our perimeters to make sure that nothing can actually get through. Think of it like walls on a castle. It's that same idea. Okay, we're stopping the bad guys from getting in. And then high availability means that, it's just if something happens, like let's say a physical drive dies, we're using a technology called RAID in order to be able to put a new drive in and have it rebuild the array, so that way we have access to it. And we'll get to RAIDs in future lectures. Okay. So another way to think about this is protecting data is when it comes to intellectual property. So these are things that you create or your company creates, or are important to your brand. Okay, because this is, at the end of the day, this is data, whether it's data on how something it was built, or something artistic in that you guys drew a logo or whatever that might be. So the first thing is copyright. Okay, when it comes to copyright, it is automatically granted as soon as pen hits paper. It is, or I guess button is pressed on a camera, or paint on the canvas. When it comes to an artist, as soon as that happens, it is now that owner's. Okay, so it's important to note that this is not ideas. You can't copyright ideas. You can't be like, well, I thought of Twitter before they came up with it. That's I copyrighted it. Well, it doesn't, like, you have to it has to come to fruition. It actually has to be a some type of work that is completed. Okay. The next one is a trademark. Okay, a trademark is your name and logo, and making sure that we can't have, if we had a golden arch and maybe then we had a off gold arch, for McDonald's, that would be really confusing, right? I mean, if the logos were all the same, they just used a different shade of red or a different shade of gold, that would be confusing. So that's where trademarks come in, is making sure that two logos don't look alike to protect customers. Okay, they want to make sure that the customers know they can represent, or they know the trademark, which is representative of that very specific business. Okay. A patent is something that a company can apply for. Actually, I take that back. I think only a person can hold it. I could be wrong, because I think companies have bought patents. But anyway, that doesn't matter for this discussion. A patent is a legal protection for a invention or a design of something. Okay, and the three things when it comes to a patent is must be original, useful, and distinctive. Okay, so I couldn't patent a piece of steel that does this. And when they say, what is it? I don't know. well, that's not very useful, right? Like, it's a piece of steel. No, like it actually has to have a purpose. So if it was a piece of steel that was shaped like this and it went on your house to reinforce your gutter, and it's a super lightweight something or another, it has a camera on it so it can check your leaves in there or something. It has to be something that's very useful, different than what's already been out there, and also must be a original idea. And then you also have to apply for it in different jurisdictions. So, in the US, we have our patents, but other areas have a different process that you would have to go through. And then finally, digital rights management, or DRM. This is software that's put on different digital forms of like media is where you normally see it, to protect that original author. Really, DRM, I mean, you'll see a lot of people kind of fight against it online, because a lot of times it can be a little overreaching. But for this, again, another homework assignment, just do a Google search for DRM, the pros and cons of it. But for the test, you just need to know that it stands for Digital Rights Management, and you usually see it in types of like digital multimedia. Okay. When it comes to this data that we're protecting, why is it so important? Like, yes, we talked about, customer data, but data as a whole, why is it important? Well, data helps us drive where our business is going. So when it comes to like Amazon, being able to track what things are being purchased, so that way they know how much to work with its vendors in order to bring that into the warehouse, into maybe there's a lot of things being ordered down in Southern Ohio. Well, maybe we need to look at having a distribution center there, in order to, speed up that delivery rate. Okay, so there's several different ways that businesses utilize that data that we're talking about in order to make informed decisions. So even me, as a school teacher, I look at data to influence where I need to maybe reteach a concept, whether, I might look at test scores and they might be like, hey, that's, we're good there. We can move on. We have seen mastery in this subject and we can move further. Okay, so every aspect of business, hospitals, law enforcement, everything uses data in order to make decisions, because at the end of the day, we're always trying to, do more, usually with less, to be more efficient, to be more productive when it comes to our daily life. Okay, so what is that relationship to data? So data is just raw information, or I'm sorry, that data is just raw bits and bytes and things like that. But when we add context, when we tell a story with it, that's when it becomes information. Okay, so data is just raw values, and then once we actually can look at the data, we can then infer different points. That's when it becomes information. Okay, and that information is what helps guide our business when it comes to, analytics and stuff like that. Okay. So how do we do this? By doing data collection, data correlation, and then reporting. So we have our data. We capture our data in some way, shape, or form. We go through and correlate the data. Look at everything, all of our, let's say it's a quiz. We look at all of our quiz results or our survey results. We correlate all the data, and then we report out what did we find. Okay. So again, it's kind of a weird place to put this, but again, it's such a small part of the test, knowing kind of how business or how data drives business, because in IT you have to understand that we a lot of times we just look at the data as just that, as just data, but at the end of the day, this data is what drives what our business does. So we have to protect that at all costs to make sure that we have good data and the right people are the only the good people are working with the data, making sure that it's secure, making sure our firewalls are working, our login, all that stuff. So that way our business can make good decisions to kind of navigate that ship ahead. Okay. So In this lecture, or in this module, if you will, you should now be able to recognize and use different notational systems. Do you remember what they are? Yes, good job, you did. Yeah, base 10, base 2, or binary and hexadecimal, and how we use those to measure things like storage, throughput, and processing. Do you remember what those three, how we represent those three? Gigabits, or bits per second, gigahertz, or cycles per second, and then what was that last one? We said bytes, and that's how much storage, so gigabytes of storage. Compare and contrast fundamental data types and their characteristics. So we talked a little bit about Boolean, which was true and false. We talked about floating point, which were our decimals, our integer, which was our whole numbers. Those are all things that we're going to use when we get to the programming section. But just right now, I just need to plant that seed just so you have knowledge of those things. And then we talked about the importance of data to businesses, okay, and how businesses can make data-driven decisions. So what I'm going to do is I'm going to put some quiz questions up on the screen, let it pause for a second, and then see how you did on those questions. All right, so I hope you did well on those quiz questions. If you did not, feel free to go back and rewatch the video, or you can always put, something in the comments. I'm not perfect, so if I can, answer that question, or if I can clarify it a little bit better for you, then I will absolutely do that for you. So thank you so much for joining me on this module today. If you need absolutely anything, feel free to reach out, TJ@tjhouston.com. Thank you and have a good day.